cleaning technique. So clean text function. Here we are adding all the things, remove the HTML tags, remove the numbers and all, remove a special symbol, take only alphabets, all these things. So this function has been created. Once this function is created, we will be creating a clean text over here. Now you can see similar steps we are repeating over here, right? We are repeating the similar steps. So df clean text, taking the text and applying the function on clean text will be yes, we will be getting the clean text now. And if you are going to see the comparison, here you can see the comparison. So few things will get removed, few things will be same. Now you can see this bracket was there, it got removed, right? So this sign was there, greater than, that sign got removed. So these are the cleaning thing we have done. Now what you can do, like if you want to use TF editor vectorizer, you can use, but here we will be using something else. What is going to be there? Let's try to understand. We are going to import from TensorFlow.keras preprocessing text. So from scikit-learn, last time we have used preprocessing.txt. From Keras we are using tokenizer. Now we have one more thing from sequence, preprocessing.sequence. We are importing pad sequences. Let's run this. Let it get imported. Fine. So what we are going to do, we need to tokenize. Tokenize means what? We want to break down the numbers into chunks. We want to break down the numbers into chunks, so it will get broken down, and let it get broken down. So we'll be applying fit on text. Tokenizer object we have created. Number of words we are saying, take 20,000 words, tokenize those 20,000 words and apply it on clean text. Next thing we have text to sequences. Sequences means what over here? We are talking about the numbers over here, right? So not exactly in the numbers. So text sequence will get created, and in the text sequence we will be adding padding. What does padding is there? Let's try to understand. Let's run this first of all. So we are creating X over here. What does pad sequence means? Sequence, max length, what exactly it means? Let's try to understand. Let's say you have tokenized some words. You have from here to here, and what you have, let's say you have 200, or let's say you are having 500 words in a particular token. So like 500 tokens you are having at a time. The term padding, what does it mean? Padding we have taken 50. Now the next token that you are going to create, the next padding part that you are going to have, so it will be having last 50 from here, this 50, and using this 50 you will be creating next 500. Okay, now in the next 500 we will be having this particular 50. Okay, this is how the things will go. So we will be taking 50-50 and we will be combining so that it will not remove the context. So once the padding is done, we get the clean text and all. And what we are doing for Y, that is a target feature, we are taking a data frame of emotions, right? These are the emotions. We have taken the data, and like to train, and for training and testing purpose we need to split the data. For splitting the data we are taking the same scikit-learn.model selection train test split. We are taking xtrain, xtest, y train and y test, x and y independent and dependent data. Test size we are given 30%. 0.3 means what? 30%. Random state 42. That means 70% data will be trained and remaining will be tested. So our data got splitted. If you're going to see the type, so your training data is also in numbers, your testing data is also in numbers. Okay, here only with the help of sequences we are able to convert it into numbers, right? So the x that we have, that has been converted into numbers, it has been stored over here and it is having int32. From int32, what we want to do, we want to convert it into float. Here we will be having it into the form of float. Let's run this. Done. Now here what we will be using, here we have concept of single direction and we can say forward and backward direction also in RNN. So we are going to use RNN technology to train the model from both forward and backward. What does it mean? We'll see. First of all, what we need TensorFlow to create the models and all, Keras to use sequential model, and in layers we will be adding multiple layers, that is embedding, bidirectional, LSTM, dense, dropout if it is required. Dropout, if you remember, it was there. So we'll be importing all the things and then we will be having this particular thing. So in model, what we have, first of all, we are having embedding. Embedding basically is going to be nothing but the particular layer that is going to work with the numbers that you have. In embedding, what we are doing, we are giving that we will be passing 20,000 uh, 20,000 inputs. Output dimension 120. We are keeping it 120. Input length is 50. So this is what embedding is going to have. Then you have bidirectional LSTM. Now before getting into LSTM and what you can say the RNN on, let's try to discuss this topic RNN, how basically it works, a recurrent neural network. First of all, we'll discuss it and we'll come back over here. RNN stands for recurrent neural network. Recurrent neural network. Now what exactly we have, if you are going to talk about the architecture of RNN, so basically let's say you have a neuron or you are having a layer, okay, and it is coming back to it. It is coming back to it. It's coming back to it in the sense we are talking about based on time interval. Based on time interval. How we can represent this thing? Let's say you are getting input over here. Let's say this is the input, okay, and the input. So this particular neuron, I'm just representing it over here as a rectangle. Let me fix this like this, maybe. Fine. So here, let's say it is same. It is same. Whatever the inputs or output is going on, it is coming back to it. It's coming back to it. It's coming back to it. Now it is nothing but, let's say it happens on t. It happens on t plus 1. It happens on t plus 2. It happens on t plus 3. We're talking about the different time interval. Okay, and why exactly we are using RNN over here? RNN, because when it comes to text, if I'm going to write down one word, let's say this is a sentence. This is a sentence. Now if you want to get the context of this particular whole sentence, now you need to relate this with is with a with sentence, right? A with sentence. Perfect. I hope it is making sense. Now in RNN, guys, what exactly happens, like we can see multiple types of relationship also. Multiple types of relationship means what exactly you want. I will come back to RNN. First of all, let's try to understand the relationships, and I will be asking you some examples based on that. So let's say I'm talking about relationship, and relationship is this is widely used, not only in RNN, everywhere you will find. I think if you have gone through Power BI, in Power BI also the models that you have created, data models, there also you have created some relationship. So relationship. So first relationship that we will be talking about, it is going to be 1 to 1. Now 1 to 1 means what? Over here 1 to 1 means what? Let's suppose I'm talking about inputs. I'm talking about input. So here also it is getting some input. Okay, it is getting some input. No matter how much in time interval you are taking over here. Now, if your input is 1, if you are giving 1 input and you are getting 1 out, this is your input and you are getting 1 out. It is going to be 1 to. Can you give me any example of 1 to 1? Anyone related to text? 1 to 1. Live translation. Okay, live translation is fine. Anything else anyone wants to add?
तो चाले से ऑनलाइन चले.
Can we take it as synonyms?
Suit you?
Synonyms and what we call it, antonyms, like similar word, opposite word. If I am giving good, opposite of good, bad. Not bad, it is bad. Now this is 1 to 1 relationship. 1 to 1. 1 to 1. Moving ahead, what we have? We have 1 to many. 1 to many means what? If I'm going to show you the architecture of 1 to many, let's say again we are having the similar type of architecture, but here I will be changing few things. let's say you have given one input for output. Let's say I'm going to change the color. It is connected like this, and you are getting many outputs. You are giving one input and you're getting many outputs. What could be the example over here? I'm talking about text, okay? In the relationship of text, how you can relate it. Anyone? One, too many. Okay. Let me just tell you. Let's suppose I asked about defining AI. Now, the definition of AI, that you will be getting, you are using one thing and you're getting the whole definition, right? That is going to be one to many. And let's say you are having one genre. In one genre, you will be having, let's say, song 1, song 2, song 3, right? That is, genre is one, but there will be many songs. Word is one, but you will be having many words in the synonyms. We can have one too many. Just a second, let me remove it. Antonyms, I think it's fine. Okay, it is fine. Now let's move ahead. Now what we will be having? I'm just going to write it down. Many to one. Guys, many to one. Many to one. What does it mean? Many to one. I'm creating the same architecture and here I will be changing the outputs. Alright, so let's say you are getting many inputs. You are getting many inputs. All this blue line, the blue arrow that you can see, it is nothing but the inputs. But for many inputs, what you are getting, you are getting one output. So these are the inputs. Input 1, input 2, input 3, or n number of inputs, and you are getting only one output. Any example? Many to one. Yes, exactly. Sentiment analysis, right? We have given spam detection. Very good, Nirmal. Very good, Nirmal. Nirmal has given very good examples. Sentiment analysis, the problem that we have solved just earlier. Sentiment analysis. We were giving a whole sentence, the movie review we have given, and we were getting what? Positive or negative, right? Positive or negative. Okay, then what we have? Spam detection, right? So in email you are having a long text on, you are detecting what it is, a spam or not a spam. Perfect. Books and author. Okay, books and author, multiple books you are connecting with one author. Okay, books and author can be take. Okay, weather prediction, many to one. Okay, Prasant, I will be asking sir to join, at the end of the session. He will be taking up your doubts, okay? Whatever doubts you have. So those who are having the, the doubts regarding to the LMS, the last 20 minutes I will dedicate of today's session for you, for your doubt clearance and all. Okay. Fine. So we got many to one. Now, the last one. What could be the last one? Last one is going to be, yes, exactly. We will be having many to many. Many to many. Let's say we are having similar architecture of RNN. All right. Now, let's say you are getting many inputs. Inputs, let me take it as blue. You are getting many inputs. And what you are getting in return of many inputs, let it get connected. You are getting many outputs. Now, give me example of many to many. Anyone? Yes, very good example, Nirmal. Let me take others, then I will take. Guys, I want everyone to at least reply something, okay? It is not like that only Nirmal and Dhruv is replying. Summary, yes, summarization, summary. Actors and movies, okay. So one example I'll take over here, that is nothing but you have given a long text and you are asking for the summary, that is text summarization. And can we take this one, guys? Language translation. Language translation. If I am giving a long text, आज आपने खाने में क्या खाया? Right? What do you eat today? Where are you going? आप कहाँ जा रहे हो? Right? So multiple things we are giving and multiple things we are expecting. That is many to many. Are the relationships clear, everyone? The relationships are clear. Perfect. Now let's talk about the RNN exactly. What exactly RNN do? If we talk about the simple architecture of RNN, let's say we are having a box. I'm just taking a simple box, and you will be getting, like, it will be interconnected. So you will be getting the, let's say you are giving the input. Input will go here. You may have one activation function. For time being, I'm taking the activation function as tan h. Okay. So activation function, I hope you remember. Activation function, and it will go beyond. Okay. And here you will be having the output with the time, let's say ht. And again, so this thing that you're going out, it will come back from here and it will join it. This is the simple architecture of RNN. But RNN is not directly, feasible solution. RNN is not always the feasible solution. What we use, so what we have, we have limitation over here. So RNN is fine. So neural network basically we are handling for sequential data. Sequential data, when it comes to sequential data, we are talking about text only, a text sequence, right? So unlike different feed forward network, so whatever the network that we have used neural network like CNN, or we have used ANN. So these are the feed forward neural networks. So they have loops that let them keep information. Like unlike that particular thing, like in ANN, in CNN, it's just going forward over there. But here in RNN, it have loops. Like you can see whatever it is going out, it is coming back over here. It is coming back inside. Okay. So we have loop here that helps the RNN to keep the information from previous steps. Whatever the previous step was. So one example I have given you. Now, let's say you are having a word over here, one sentence. This is a sentence. So you're having a sequence over here. Now, if I'm going to break the sequence, the context of the sentence will get over. Right? Context of the sentence will get over. That's why we are using RNN over here. So input layer is going to receive the sequence data. The hidden layer that you will be having, it is going to process the input, and it will maintain the information from the earlier time steps through the recurrent connections. Okay, and output is going to generate the predictions. So on the current hidden state. So this is the hidden state. So HT, we are calling it as hidden state. Sir, at the end of the session, can you please talk about the project? For LMS and all the things, I will be requesting Tawfiq sir to join. He will be conveying all the all the things to you. Okay. Let me complete my part, then I will be asking Tawfiq sir to join, and in meantime, you can also fill the attendance form and all. So RNNs basically perform well on short sequence, but it may struggle when it has to capture long range dependencies due to their limited memory. Now what we have limited memory over here. Memory is phase away. It may forget the things. So this is what the limitation we have. So we have one problem with RNN, that is vanishing gradient problem. So memories also fades away. As the sequences grow longer, they struggle to remember the information from the earlier steps. So basically, this is going to make it less effective, and it needs the understanding for the long-term dependencies that it doesn't have. Like, let's suppose I have to do translations of something, or I have to perform speech recognition. So that time we will get some particular problem over here. Now, to overcome of this particular problem, what we do, we use, any idea what do we use? Anyone? What do we use? Yes, exactly. Yuvraj, Nirmal, right? We use LSTM. LSTM stands for long, short term memory. Guys, have you watched the movie Ghazni? Anyone? Have you watched the movie Ghazni? Yes. What type of disease that particular hero was having? Whatever disease the hero was having in Ghazni movie. Yes, short-term memory loss problem. The same short-term memory loss problem your RNN is having. So that's why we implement LLM. Sorry, not LLM. We use LSTM over here. So these are going to be the improved version of RNN. That is basically designed to solve the vanishing gradient problem. So basically it use the memory cells to keep that information over longer period, right? And what exactly LSTM is going to have? It will have input gate. So here we have input gate, guys. Okay, this is XT. We are going to call it as XT. This is input gate and HT is output gate. Input gate and output gate. But there will be one more gate in LSTM. We call that gate as forget gate. So input gate is going to decide what new information to store. Let me write it down over here. Okay, better I write it down, so it is going to be good for your reference. So if we talk about input gate decides, let me change the color for better view. Just a second, guys. Just want to make it interactive, that's why I'm changing the colors. Input gate. So input gate basically decides what new information to store. Then what we have? We have forget gate. What forget gate is going to do? It is going to choose or it chooses what information to remove. Finally, we will be having output gate. Output gate what decide? It is going to decides what information to simply pass on. Okay, let's talk about the architecture over here. So this gating system allows like this gating system, when you are having the forget gate, input gate and output gate, so basically this gating system allows LSTM to remember and forget the information selectively, and it is going to help in making them effective at learning long-term dependencies. Long-term dependency means what I'm talking about: a paragraph, context of the paragraph. If I have written something, the paragraph should having some context. What is that paragraph all about, right? And yes, LSTM works well when you are going to work on the sentiment analysis task, speech recognition task, and language translation. Mostly language translation, we are using LSTM. Okay, let me just create a simple diagram of LSTM. So I won't be able to create, the all the things. Let me just take it as of now. Okay, now a lot of things will get included, guys. So first of all, one line will pass over here. We'll be talking about each and every line. So you are taking the input from here. Okay, you are taking the input from here, and this input will be having multiple, gates over here. We will talking about the gates, and it is going to get, first of all, connected with over here. We will be adding a forget gate. So this X is nothing but forget gate, right? And one line goes straight from here. It goes straight from here, in and out, right? And on this line also you will be having one forget gate. So this X is nothing but forget gate, right? Now here whatever the inputs that you are having, input is nothing but your xt, I'm taking it as input, and you will be having one output over here, ht. I will be talking about it. So we are giving the things from here, and now here I'm going to create few more things. Now we can have multiple functions over here, activation functions and all. Let me create some context over here. Squad, one more squad, one activation function, one more. So basically it goes like this. It goes like this. Okay. So this particular thing is also a forget gate. Forget gate. Let me write it down. This is the forget gate. Now here, so whatever you are having over here, like this, here like this, and here these things over here till here, these are going to be, let's say this particular part till here, these are input gates. These are the input gates. Now here that you have one thing, I guess I'm missing out. Yes, not here, it is going to be here. Okay, it is going to be here. I won't be able to remove this thing. Let's say you are having, this is going to be your, this part is going to be your output gate. Right. It's sometimes it's tough to remember all the things. Here you have, let's say you are having one activation function. Let me just put the activation function over here. Activation function that you have, let's say tan h, right? Here it will also get connected in between. Here also you will be having one forget gate. I'm just putting it over here. Forget gate. Multiple times the gate will be there, and yes, inputs are coming from multiple direction, and here it will get over here, guys, it will get added. Let me just write it in the green box. Here it is getting added. Okay, here it is getting added. Now from here, this forget gate, we are also going to get few things over here. Those few things are going to be nothing but again some information that it is getting passed through activation function, calling it as tan h, and this information can goes like this. Information can goes like this out, and it can go over here down. Okay, lot of complexities, but let's try to understand. You are giving the input. Okay, these are the input gates. Your inputs are going on. It is also going through the forget gate. So whatever it needs to remove, it will get removed from here in between. Whatever need to get preserved, so from plus sign it will get preserved. Now here you can see two lines are going out. Two lines are going out, and two lines are also will get joining over here. This is the concept of bidirectional. Bidirectional. Okay. Bidirectional means what? Two directional. So you are having multiple inputs and you are having multiple outputs also. If I'm going to tell you in this particular context over here, whatever it is going over here, it is coming back. It's coming back. To remember the context also. Okay, that is the concept of bidirectional. So this is the whole story of RNN plus LSTM. Let's come to the file over here. Here we are going to create the model, and what we are doing, we have added the embedding layer, bidirectional, that is the LSTM with 128 neuron. Return sequence is true because it is bidirectional. Dropout, here I have added dropout. If you want to take it, you can take it. Otherwise, if you want to remove, you may remove. Then we have bidirectional LSTM again with 64 neuron. Dense, we are adding one dense layer. And dropout here I'm adding in between. If you want to remove dropout, you can remove. It is not like that I have created it this way, you have to create it the same. Once we are done, we will be compiling the model. Okay. Here I have taken the loss as binary cross entropy. Why binary cross entropy? You will say, sir, we have only zeros and one. But if you see, each particular column is going to have 0 or 1. So we are thinking in that particular. Once it is done, we are going to, so here we are also applying the early stopping over here, patience 4. Let's fit the model. Here we are using 20 epochs. X train, Y train, X and Y we are giving. Validation data, we have already given test data. Early stopping we have added. Now if something is getting wrong, it will have the patience till 4 epochs and it will get completed. So our training has been started. Let it get completed.
हाँ तो बायनो ढकाएगी पोते पोत
First epoch will always take a lot of time. Okay, so you have to be patient over here in the first epoch. Till then, anyone having any other doubt other than related to LMS and all? I have already informed sir, he will be joining. Once he join, I'll let you know. Then start posting your doubts. Clear till here, everyone? Are you getting it? What exactly we are trying to do? Can I get some thumbs up in the chat? Perfect, perfect. Now, there might be some confusion. There might be some confusion. The confusion will get removed once you are going to work on 2 to 3 projects. Okay, still if you are having confusion, then let us know. But you have to work on it, right? When you are going to implement, when you are going to change something, then you will understand, if I'm changing this thing is happening. It's all about practice, right? So you can consider it as mathematics, how you learn mathematics. Let's say maths, if you are not going to try for 1 week or 1 month, you will forget the things. For sure you will forget the things, or you will become slow in calculating, right? If you have studied a theorem in 10th class, if I'm going to ask you the same, most of you won't be able to tell me, because you're not practicing it. So it's all about practicing. If you want to be updated, you have to go through each and everything at least once in a week. Because in interview, people can ask you questions from anywhere, anywhere. So if you are going back to your projects and all, you're looking into the things, you will be able to explain. And one more thing, guys, when we are talking about projects in interview, I'm talking about in the context of interview. In interview, most of the things will goes around your project, the project that you have added in your resume. One common question will be there in all interviews. So interviewer will ask, have you worked on any project? And definitely you will say yes. So they will ask you to explain your project. Now, how you're going to explain your project? If you have not worked on any project, you have just copy and pasted from any, like someone's GitHub, or you have taken from Kaggle directly, someone's written code, you won't be able to, I know, explain. So you have to work on the project first of all, end to end. Try to do end to end. One project, two project, you will feel some difficulties. But when you're going to start a third project you will do in very less time. Yes, there will be some complexities, but you will start handling the complexities very efficiently. This is what the companies want. You will be having complexities, you will be having the problems, but how you tackle the problems. Once you are going to work on lot of projects, then this thing will come automatically. All right, so what are our findings as of now? The findings we have, if you look into the findings, we have accuracy very less, 21%. AUC score, validation accuracy is only 33% for the first epoch. Let's wait to the last epoch. Okay. Okay, someone has requested me for the access. Guys, I think you are requesting the editor access. I can't give you. I can see someone has asked me for the editor access. Sorry, I can't give you the editor access for the file. If you are going to edit it, you are going to make changes, what I'll do in the next session, just try to understand. Download the file, whatever the changes you want to do. First of all, what I recommend, create a copy. Whatever you are doing now, here also let it get trend. You have this option, save a copy in data. If you want to make any changes, if you want to make, do it in the copy. Keep the original file with you. Okay, don't make any changes in the original. Fine. So yes, this is a time taken process. Guys, till then you can fill out the attendance. I'm just stopping the screen sharing for now. I will start sharing the screen. Let me just copy and paste the just a second. I'm giving you the attendance link and the feedback form link. Till then you can fill it out. Attendance link I have given in the chat, everyone. Mark your attendance. Go ahead and mark your attendance. I'm also giving you the feedback from the day of the day. Attendance is done. Now feedback form. Just wait for a second. I'm just calling sir. He will join and he will resolve your doubts. Till then, I hope all of you are in this running phase only. All of you are running. How many of you are trying this project with me? Can I get some numbers? Thumbs up, or you can mention me in the chat. All right. So Vishwa Kos says Hardik, very good guys. All right. So I'm just taking sir on the line. Just a second. Otherwise, Topic sir will come and join and he will give you the information. Okay, don't worry about the LMS part and all. We have a long time, right? And there is no time limit for you to complete the things. Sorry. Okay, I wanted to ask all of you have filled attendance form. I'm giving it again. Just a second. Training will take a lot of time. Okay, so have some patience. Don't leave the session. Once the training is done, I will be also showing you the output of the trained model. The model that we are training, we are going to see the output of the trained model. How basically we are getting the things done. Thanks everyone. Attendance is mandatory for everyone, so that's why I'm sharing the link again. Fine. Apart from that, if you have any doubt, you can ask me. Still have time for completing the training and time for our discussion also. Let me know if you have any apart from LMS. Anyway, have you completed any certificate yet? Have you uploaded on LinkedIn? Are you uploading the certificate? Yes or no? Yes. So if you are uploading on LinkedIn, are you tagging Microsoft, Elevate, your college, your faculties? Okay, 31st of March. Okay, so I will collect the information, guys. Don't worry about it. Yes, half of the modules are remaining yet, so you have time in your hand. Request to show demo file of a working project or show us in a session. So I'm showing you the project only, right? Hey Taxi, we are working on the projects only. When it comes to the project on Azure on all, like on the cloud, like Copilot Studio and all, that is going to be the last part of our sessions. Excuse me. So we'll be discussing on just a second, guys. What the project will be about, what is going to be the format of your project, the report, PPT and all, we will be discussing. Okay. Difference between ANN, CNN and RNN. Look, ANN and CNN are feed forward net, right? It goes forward direction. In ANN, we are simply taking the input features and we are giving it to the neurons, we are adding into the layers. Okay. But in CNN, we are convolving the features. We are extracting the relevant or important features from the image, and that we are putting forward into the fully connection layer. In ANN, directly we have fully connection layer. We have input and we have fully connection layer. But in CNN, first of all, we are having convolved features, then we are pulling out the important pixels images from there, pixels values, and those values finally we are taking it at input feature, and that input feature will go to the neural networks. Okay. On the other hand, RNN, RNN has the capability of going back. Okay. So it is recurrent. It is to stand for recurrent neural network. So you can see I have shown you like this, recurrent. So it is coming back. The input that you are giving, it is coming back. And here we have the concept of bidirectional. It can go back, it can go forward and it can come back. So taking the context. So basically RNN we are using only for the most of the time to solve sequential problem. Sequential either related to text or related to time series. Time series, one problem you can solve using RNN, that is going to be stock price prediction. Now stock price is based on sequential data. What sequential data? Time sequence. So here, as of now, whatever the problem we are solving, it is text sequence. But in meantime, you can also work on time sequence problem also. For time sequence and text sequence, we use RNN. I hope it is clear. ANN, CNN, RNN. Any other doubt you have? Hey Taxi, the project and all we'll be discussing in our next session, right? LMS also, look, two things I will be answering in the next session related to your project and related to your LMS. Okay. As of now, I have less knowledge about these two things, so I will get it confirmed, or one more sir will join and he will explain you. I'm not able to download the certificate from the website. Are you talking about MS Learn website? So you won't be getting certificate from MS Learn. You will be getting from LMS. That is Elevate. Elevate.5. Any other sort of doubt, guys? Sorry, I'm having cough, a lot of cough today. So Any other sort of doubt, guys? I want you to show the output. Still, we have time. If in 10 minutes our training is not done, why accuracy is low? Now you can see accuracy is improving. It was started with 21%, and in the fifth epoch only you have achieved 40%. We have 15 more epoch. Okay, don't judge it too quickly. We should not judge anything too quickly. Okay, let it get completed. If it is not done in 10 minutes, I will show you the things in the next session. Okay. Best sources for learning data analytics. You have na MS Learn platform, and if you're talking about the books and all, I can recommend you some books. You can take. Do I have any book here? No. You can, like, I can't promote. I'm not promoting. There is a publication called O'Reilly. So if you have good habit of reading books, you can go with O'Reilly. Talking about YouTube channels, I'm not talking about the channel that is going to show you the coding and all. I'm talking about a channel that shows the concept. So there is a channel called 3 Blue 1 Brown. 3 Blue 1 Brown. You can learn the concept from there. Concept of each and everything. Sir, what are your views on people leaving the country versus staying in the country? Look, it's their choice. Pratik is saying in Elevate 5 where to view certificates. Pratik, anything related to LMS, I will be answering in the next session. Let me just confirm it from the team. I will be asking all the LMS related queries, project related queries in the next session. Or one more sir will be there, he will be answering your doubts. People living the country or staying in the country. Why do people leave country first of all? When let's say money is the first priority, for most of us it's the first priority. And why do people leave? Let's suppose, just giving you an example. If you are earning 10 lakhs over here in India, 5 more minutes guys, and after that we can wind up the session. Till then, you are having any other doubt, you can ask. Okay, you can ask doubt from out of the box also, like from whom I got this particular question.